because I could dump out at you reams of stuff that I've heard, but a lot of it I don't really believe, and I don't think that's not the most productive way to proceed. So it seems to me that the top-level story about this whole .NET thing is that the goal is to move into the wonderful world of everything being networked, while still keeping the client machines important. Because the client machines, after all, are where Microsoft's biggest strength, not where our only strength is, but where our biggest strength is. And so the thing that would be least good from a strategic point of view for Microsoft is to move to a world where all the client machines behave like terminals. And there certainly are plenty of people who would like to see that happen. Now, my personal opinion is that that's not likely to happen anytime in the foreseeable future, just because the server infrastructure is not reliable enough. You know, even within a moderately well-managed organization like Microsoft, the service infrastructure isn't that reliable. And I think out in the great world, it's much worse. But more than that, you'd like to have a positive story to tell about why you want to stick with client machines, not just a negative story, but I'm forced to use these horrible client machines because the clowns can't make the server infrastructure work, but I'd really be much happier with servers. That's not the story we want to have. So I think that's a good top-level view of what the whole thing is about, recognizing the reality of the internet and everything being connected and so forth, and yet wanting to deliver a lot of added value from the fact that the client machines are powerful. So I think there's, from a technical point of view, I can see three aspects to that. One of them is the user experience, which is probably the one that's least relevant to you guys. So we want people to be able to interact with their computers using speech and writing and more local intelligence on the machine that can make it behave more sensibly in an interactive way. So, you know, smart tags and all this other whiz-bang stuff. And I think that stuff is cool. And in fact, I'm currently working in the tablet group where the primary issues are indeed user experience issues. And if you guys want to talk about that, that's fine with me, but I wasn't going to say anything more about that here because it didn't seem particularly relevant to what this group is doing. Second thing is to get rid of all the underbrush that people currently experience that has to do with managing your PC. So that's everything from synchronization to software installation to backup, all the things that currently mean that you have to worry about the complexity of the client machine. And there doesn't seem to be any fundamental technical reason why all that complexity has to be there. It's there, I think, for two reasons. One is historical. There probably were good reasons 10 years ago why it had to be there, just because we didn't have the computing resources to deal with these problems adequately. And the other is that historically, I think it's been very, well, historically, hell, it's very countercultural for Microsoft to actually attack this problem. Right? Microsoft is full of people who like to grapple with the complexity of the PC. And I've just been, well, I guess this is long enough ago that I can tell this story now. When I was interviewing at Microsoft 5.5 years ago, I was talking to Bill, and one of the things I said to him was, you know, Bill, there are a couple of studies that have just come out that claim to show that it costs a corporation somewhere around $8,000 or $10,000 a year to own a PC. I'm sure you've all heard this total cost of ownership story. But the beginning of 1995, it was relatively new. And you know perfectly well that Microsoft gets only a tiny fraction of that money. If we could reduce the cost for the corporation from $8,000 to $5,000 and keep a third of it, we could double or triple our revenue from each company. Wouldn't that be cool? And that seemed to me to be a very good story at the time. It still seems to me to be a good story. But Bill's response to it was to get up from his chair and start to pace up and down the room and try to convince me that at $8,000 a year, the companies are getting a bargain. Which might very well be true, but it seemed so irrelevant. So this is a deep problem I think we have in this company, is that people don't really think that it's important to do this. But I think it is important, and I think more and more people are coming around to the view that it's important. And I think that some of the things that you guys are doing have quite a bit to do with this, because issues of how you control the configuration properly and how you instrument what's going on in the machine so that you can figure out whether the right things are happening and all that sort of thing, I think are critical to making this work. The idea that somehow you're going to do this by creating some magical perfect system image and installing it on the machine, and after that everything is going to be perfect, I think that's not realistic at all. It's going to have to be a much more dynamic process to make this work. And from the top level, I think the way you approach this is just to ask, what are all the things that bother the user of a client machine? And how many of them can we get rid of? And my personal view is the things that are the least important are the occasional annoying error messages and bugs and so on that show up. That does happen, and it's kind of a pain, but that's not what's really bad. What's really bad is when you have to spend several hours doing software installations, or when backup isn't getting done properly for one reason or another and you lose your work as a result of that, or when you can't figure out how to configure the stupid network. Kinds of things that actually happen routinely, as opposed to things that happen because of some specific mistake that someone's made in the engineering. So that's a second very important aspect, I think, of this whole .NET game. And this can only increase in importance as we have more and more devices which get more and more complicated internally. So today your cell phone is a pretty simple thing and requires, well, when I buy a cell phone, it only takes me about an hour and a half to configure it, which is not that great, but it's not a lot better than a PC, but it's definitely going to get worse, and that's a little bit unfair, too, because only 5 or 10 minutes of that hour and a half is spent doing things that are comparable to the things I have to do on the PC. Most of it is spent because of the fact that there's no way to download my address book into the cell phone automatically, so I have to punch in a whole bunch of addresses and phone numbers by hand. But definitely things are going to get much worse with the cell phone and any other kinds of random gadgets you have. So this issue I think is going to be quite pervasive. Sometimes this gets lumped under user experience. And I think that's really a mistake, because I mean, it's true that struggling with the configuration of the machine is part of the user experience, but all we're really saying here is we want that to go away. It's not that we want to redesign it or change it. We just want it to disappear as part of the user experience. So I don't think it's very helpful. It doesn't help us to think about it much to call this part of the user experience, except to the extent that it stops us from focusing on improving the design of the 12 windows that you see when you're installing a piece of software. That's not a rewarding thing to do, because you want those windows to all go away. And then the third aspect, which is the one that certainly gets the most emphasis in the interactions with the press and the spiels that you heard in Forum 2K and so forth, is the business of services on the net. And the fundamental thing that's going on there, I think, is if you think about the way the web works today, the most important thing about it from an engineering point of view is that the consumers of web services are people. And the consequence of that is that there is an interface that every web service presents to the world, but it's not an interface that's designed to be used by programs. And a slightly overstated way of saying this, but one I think is good to bear in mind, has a lot of truth, is that the reason that the web is so successful and is able to run on internet time is that it doesn't have to work. Because whenever something goes wrong, there's a person at the other end who will respond in some appropriate way by retrying or going to some other site or coming or whatever. And if the page comes back looking a little bit weird, this happens to me, maybe one in 10 or 20 or 30 pages that I view, little fragments of HTML angle brackets pop up because somebody did the wrong thing, like constructing the page. Now, if a program sees that stuff when it's trying to understand a web page, it's almost certainly going to go off the deep end. The best you could hope for is that it will just say, sorry, can't proceed. But quite often, probably, it's going to parse those angle brackets as names of people or whatever, and then God knows what it will do. So there's really a fundamental difference between a service that's designed to be consumed by a program and today's websites, which are designed to be consumed by people. So the vision is that the web is going to be full of services instead of full of web pages. And the reason this is significant from the point of view of the overarching goal that I described before is what it means is that you can sit there on some other machine, and in particular on a client machine, and you can have programs that run on the client machine that call on these services all over the network and then do something more complicated or different based on what they find out from talking to all these services. Today, it's extremely hard to do that. So, a concrete example, a significant advantage that a company like Amazon has in the marketplace is that they know your buying history. And they customize their site based on that. And they own that information. You don't own it. If you want to go to Barnes & Noble and have them customize what they show you based on what you bought at Amazon, you can't implement that. Now, this is good for Amazon, but it's not especially good for the consumer. From the consumer's point of view, it would be much better if that information went everywhere with you. If you could extract that information from the Amazon site and store it on the user's machine and then present it to some other site, then you could accomplish that. So I think you can see just from that one tiny example how much scope there is for changing both the user's experience and indeed, in a deep way, the functionality of what you get out of the network. If you can move from a world in which what gets presented over the network is web pages to a world in what gets presented over the network is services. Now, today, if I wanted to implement the little idea that I just described, the only thing I could do is write a screen scraper that would go and poke the Amazon site and look at what pops up, and there probably are buttons I can push that give me a list of the last few books that I bought from Amazon and so forth, and I could try to write a program that would scrape that stuff off the screen.
You can list all books that are bought.
Cool. Right. So I could write a program that would extract that stuff out of that list, and then of course what Amazon would do is change the format of the list once every couple weeks in order to make it more difficult for me to write that program. And then what I would do is find out right away when they change the format and write a new program and have it automatically done. And so you can see how this would go. It has a lot different. If you have to do it today, it's going to have a lot different flavor than the way you would do it if you actually engineered the net to be services that can be consumed by programs. And so I don't know how many of you watched any of the Form 2K spiel, but you probably remember the example with the video of the guy who kept running into bicycles and how his medical records were being tossed around all over the place and so forth. So that's another perhaps more aggressive example of the kind of thing you could hope to do if all this stuff that's stored somewhere on computers is actually accessible to programs. And so it seems to me that the most difficult problem that we're going to face, we're going to face a couple problems in trying to make this work. The first one is testing. How are you going to... Today it's not that important to test websites because they don't have to work. So if one time out of 20 or 30 clicks it does the wrong thing or does nothing, and that's not ideal. You'd prefer that number to be lower. But it's definitely better to have cool new features than to reduce the number of bad pages from 1 in 20 to 1 in 50. Because people just are not that upset if 1 page out of 20 is bad. About the only time when they're upset is if they've placed an order, spent 20 minutes placing an order, and then you push a button and the order disappears. Okay, so there's a few things that people care about, but for the most part, it's not that critical. And so testing isn't that important. And obviously, you have to try it out to see if it's going to work, but you don't have to test it in any thorough way. That's clearly not going to be true if programs are going to be talking to these services. And how we're going to do an adequate, how are you going to characterize what the service is supposed to do so that it's even possible to test it, and then how you're actually going to implement the testing in such a way that you can have some reasonable amount of confidence that if I set up a scheme of things that requires me to talk to 6 of these services, that it actually has any prayer of working. That's a tough problem. And it seems pretty clear to me that we're not going to be able to solve that problem by just continuing to do testing the way we do it today with test matrices, because there's too many combinations that can the whole nature of this game is combinations of this stuff can be assembled dynamically. The other thing which I think is closely related is something that I already touched on in the context of the client machine. When you put together one of these complicated structures out of a bunch of services, there are a lot of things that have to be functioning more or less correctly in order for the whole thing to work. And what that means is that I think there has to be some way to instrument these things so that you can find out whether they're functioning in an acceptable way or not. So this isn't just a question of functional correctness. It's also a question of are the components actually performing adequately? And if not, can you figure out what's wrong? And again, today, this is something that we do a lot worse than testing. The ability to monitor the behavior of a Win2K system and compare it with some set of expectations about how well it ought to be working that we ship is pretty negligible. And obviously this problem is going to get much worse when you assemble these things in such a dynamic way. But also the need for it is going to get much greater because it's much more likely. First of all, it's much more likely that what you're putting together is exercising some set of interactions or whatever that was never tried before. And secondly, there's a lot more places that you might have to look to figure out what's going wrong. And the idea that people are going to go and do trace routing, sort of start from there to figure out what's going on, is not realistic. It's going to have to be much more automated than that.
Another aspect is that you're forced into black box. You don't control all these components that are out of your hand. So whatever interface they expose is what you've got to test against. You don't, unless you have some agreement, get to look at.
That's right. That's right.
So I think there's also, software components have been sort of thinking about this for a while, but now the components get distributed across a wide area.
That's right.
So I think it does really change things because you can't do even notions of coverage anymore, traditional notions of coverage for testing. What does it mean when you've got covered somebody's service over on the other side of your phone?
Right. It clearly doesn't mean anything, especially when you may well be talking to 3 or 4 instances of the service that have implemented in entirely different ways. So there's 2 issues there. As I said, one is testing for functionality, and the other is the question of can I have a model of how well the thing is supposed to be working and enough instrumentation that I can compare the way it's actually working against the model so that I can figure out what's going wrong before I get to a state where things don't work at all. And it's worth pointing out that no matter how much fault tolerance you put into the system, you still need this, because there's an iron law of fault tolerance which says that fault tolerant systems tend to become not fault tolerant. And the reason that happens is because something breaks and the system tolerates the fault, so it doesn't get fixed. Right? And so more things break until eventually you get to the point where the next thing that breaks actually overstresses the limits of the fault tolerance, and then something has to be done about it. But before that, the only way you're going to find out that you needed to fix something is that if it was instrumented. You're not going to find out because some user calls up and complains, which is typically the way you find out today that things need to be fixed.
One of the things that comes to mind as a security threat is the whole decentralization, centralization question. You can make an argument that Microsoft has a decentralized model. But if you think about it from the other way and you want a centralized model, and let's say you're AOL, then your story could be, I'm going to build everything into an AOL server. I'm going to test it that it all works together. And your sort of strategy is Fortress AOL.
Mm-hmm.
So what scares me here is I don't see a good way we can attack that. I don't see why I want a PC at home. Well, I can think of reasons, but the worry is you can argue you don't need a PC at home. All you need is connection to Fortress AOL, and it does everything for you. And they don't have these problems, and they can change their own formats, they can do their own testing, they can make sure that all their services are self-consistent, they can contract out to other service providers and force them to use I'm worried that we don't have a counter to that.
Well, I don't think we should spend too much time discussing that sort of galactic strategic issue, but I actually don't believe that Fortress AOL is realistic because the world is just too complicated. There's no way that even a fraction of the opportunities that exist for doing things with network computing can possibly be exploited by one organization like that. The phone companies have this dream too, and they've had it for 20 years. And it's just too hard. Life is too complex. And there are too many things that need to be tried. And then there's the other factor, which something that Gordon Moore said many years ago. The fundamental pattern of innovation in our business is that people think things up, often in universities, sometimes in big companies, and then they go out and do startups. And that's how innovation actually occurs. It gets into the marketplace. And there's a very simple reason for that, which Gordon explained. He said it's much easier to persuade a venture capitalist to give you money than it is to persuade the management of a successful company to try something new. And there's a really fundamental truth in that. Even Microsoft is actually very good about such things as big companies that I have any experience with go. It's tough, and it gets tougher. So the idea that all the good things that can be done, or even 20% of the good things that can be done with network computing, are going to be done by any single organization, I think that's just crazy. It can't possibly happen. The whole thing is much too dynamic. If everything would stop for 10 years, then possibly that could happen, but it's not going to.
The model I was saying is that under that model, that's exactly what happens. All AOL becomes an arbiter or broker for the latest ideas.
Yeah, that's fine, but then they can't address any of the problems that I was discussing. Except for, maybe they can make the bit paths work really well, but that's all they can do. And that's not where the problems are. The problems are not with getting the IP packets from A to B. That's not trivial, but that's the problem that we have under the best control because it's so simple. The mechanics of it are complicated, but the interface is so simple. And that's really all that AOL can do for you. AOL can't give you any assurance that when your request goes to the medical records department of hospital so-and-so that the stuff that comes back is the right stuff.
But at a higher level, isn't the problem really one between special purpose devices, fixed function devices, and general purpose platforms? It's much harder to do a general purpose platform which solves all these problems than it is to even assembling a set of existing pieces into a single fixed function.
Yeah. So I will give you my religion on this subject, which is certainly not universally shared, but I think that fixed function things are absolute losers. And it's for exactly the same reason. Things are too dynamic. The new opportunities are constantly showing up, and I do not want to have to buy a new gadget every time a new thing shows up. And I certainly don't want to carry around a new gadget. So this is why, for instance, I think the Pocket PC is doomed. Because the only thing I'm going to carry around is this. So it's going to have the Pocket PC functionality in it. And unless there's some fundamental reason why it can't, that's what's going to happen. You're not going to have a special a PIM that's separate from your cell phone. It doesn't make sense. In fact, just yesterday, Monday, Kai-Fu brought over from China a cell phone which Motorola is selling in China, which is a version of the StarTAC, except this is all screen. And it incorporates all of the Palm functionality, as well as the cell phone functionality. Now, that makes it a lot more complicated and a less special purpose of device than a cell phone, but I think it also makes it a much more desirable device. And I think that special function cell phones and special function Pocket PCs are doomed. There may be particular situations. If I'm sitting in front of my TV, maybe it's good to have a remote that's somewhat specialized. But for the most part, I think it's the same answer that I gave to the AOL question. There are so many opportunities. There's so many different things that you want to be able to do that having specialized devices for them just doesn't make sense.
Do we get examples of programs that are written by different organizations, by which I mean very different organizations actually successfully interacting on a large scale?
Yes.
Well, I mean, I can think of some sort of very limited examples where, I guess, the internet is probably the first example. But that's a very limited functionality there, and it took a long time to evolve that into something that people could implement independently. And, your description, what we're trying to do is we're trying to sort of do this, a couple orders of magnitude more.
Mm-hmm.
And in both in terms of the number of participants and the number of domains and the complexity of the interactions.
Mm-hmm. It's a big challenge. I think we have a few things going for us that make it somewhat more plausible that this could conceivably work. One of them is that we have lots more hardware resources to throw at the problem, and although hardware resources by themselves don't do anything for you, what they do is they allow you to adopt some techniques that are relatively expensive in terms of the hardware resources consumed, but that make some of these other things a lot easier to address. For instance, you can afford to do everything under transactions, and that makes it that eliminates large classes of errors that typically have plagued systems. You can afford to code everything up in something like XML in some more or less self-describing format. Definitely doesn't solve all the world's problems, but it helps a lot. 10 years ago, people just wouldn't have seriously considered doing that because it would have cost too much. So I think that's a partial answer to your question. But yes, maybe it's possible that it won't work. Well, I'm sorry. No, it's not possible that it won't work at all, but it's possible that it won't work nearly as well as we would like. It's definitely a very tough problem. That's why we're here, right? If it were really easy, you guys wouldn't have anything to add, and there would be no way that Microsoft could charge money for making this work.
So I have a related question, which is that who are we trying to convince to change their model to write these services? Everybody? Just some big service providers? For instance.
Everybody. You think big. Microsoft software on every desk, Microsoft software on every fingernail.
Yeah,
Absolutely.
So I'm thinking of situations where the people, they have personal web pages that link to other people's web pages that have certain useful information. Like there's one guy who maintains a database of travel agents who buy tickets to India, and 200 people who link to his page as a useful thing. Is it the intention that that kind of person should write his travel agent database as a service? So that
Absolutely. Absolutely.
So I have a question that's kind of related. It has to do with, so at the high level, it sounds like what you're saying essentially is that every web page becomes a program.
Well, I don't know about every web page,
Okay,
but that is the vision of
every
.NET
every
services.
web page
Yes.
is a program now, and you're interacting with these programs through some API. Okay, but it seems to me there's a tension in the sense that web pages change a lot, and that's actually why people like them, because they're constantly changing. Okay, but at the same time, if you have an API and it changes, all of a sudden all the things that interact with it break. So how do you balance the tension between needing to have stable APIs so that people can interact with them programmatically and having this kind of dynamic changing world that we have on the internet? I mean, it seems like there's a tension there.
I think the only answer I know up to that question is subclassing. That is, you can extend things, but only in a compatible way. And that answer is not perfect by a long shot.
But I think you have to distinguish between the content of the web pages changing, which is particularly what I like about the web is the stuff that's up to date.
And the structure
format
changes.
is
Right.
changing. And for programs, you're going to have to be careful not to change the format too rapidly because the context is up to date.
But I think fundamentally the answer is you can add stuff as long as the stuff that you had before still works. Right, exactly. And that's one of the reasons why XML is an important part of this.
In principle, you can, but what we're talking about is trying to build web applications by dynamically assembling these arrays of components that come from a wide variety of sources, are changed all the time, are out of your control. If we didn't succeed in making it easy for people to build and assemble reliable software from components under much more tightly controlled circumstances, if we couldn't even deliver versions of Microsoft software that didn't have problems due to component interactions, this is going to be hard.
Yes, that's true. But I think you've overstated it a little bit because it does depend on the domain too, right? If it's medical records, for instance, probably there'll be a relatively strong standardization effort undertaken by the medical community and a relatively small number of, not just one, I think, but a relatively small number of implementations of the medical record service. And people will work fairly hard to keep that controlled because they think it's important. If the travel agent wants to do something about about travel to India, he'll probably do it in a much more freewheeling fashion, and his thing will probably be quite a bit flakier, and that'll be okay. So not everything will get built to the same standard, I'm sure, and that will also help with this problem. But yeah, I think this is a very tough problem, and it raises a whole bunch of issues, not least in importance of which is, when I'm designing these services, what should I do in the design of the interface to make it more likely that things will work under these much more flexible circumstances? So I remember Greg Nelson's slogan from 6 or 7 years ago. He said, when you're building a system, after you've done the design, the next thing you should do before you write any implementation code is you should write the test program. Well, write the test program first, and this will almost certainly cause you to make significant changes in your design. And people, this is extremely countercultural in our whole industry, but I think people are going to have to adopt that strategy, or we're not going to be able to make this work.
So the thing that worries me is, if you take the medical record example, I see that as very much as medical records by doctors, for doctors, and only doctors care. Because fundamentally, they're all going to be worried about getting sued.
Mm-hmm.
They're all going to be interested about exchanging information reliably, and as far as I'm concerned, I really don't care. They just go and do that some way awfully.
That's only 1 million people are playing.
Yeah, but there's only a handful of doctors, so there's no
1 million.
Well,
Yeah,
so
that's why I said 1 million. it's small potatoes.
I'm interested in the 5 billion number, and in that scenario is my wife, who goes to some length never to use a computer, but is avidly interested in watching the days of our lives and all sorts of other things. Which one of the problems I feel with Microsoft is that we're all totally the wrong people to talk about this, because this is so out of our experience. So what I'm trying to understand is why she cares, why she'd pick AOL over a PC, and all this sort of stuff. So I can see a way that my wife would drive me to go and buy a new machine. I can see a way where she would bang on me to get some of these services. But they're all to do with taking the PC that we've got in our home, it's in the bedroom, and stick it under the TV and making it useful for her.
Mm-hmm.
She would really pay, she would really care if she could pick up the phone, call our home machine and tell it to record her favourite video program. She would really care if it would keep track of the fact that they shifted the time and it's going to get it right. She would really care if she could get some piece of irritating information that she'd forgotten off the machine by calling it, or off a handheld or something. So what worries me is that our strongest argument, in my opinion, is the fact that we can have a huge amount of local processing power that could do things for people in there that's their information, that they're in control of, and things they want to do locally. And okay, it's nice being connected to the web, and it's great to be able to get certain information from the web, but that to me, I don't see any story where we can build software or a product that my wife's going to go and force me to go and buy in the next 3 years. Where something simple like integrating a home PC and audio-visual stuff and giving her a video phone and kicking out the video recorder and DVD player and replacing that and turning it into a stereo system, I can see that she'd go and buy that within 12 months.
So that's cool. We're doing that, but that's not particularly part of this .NET story. But certainly there's a bunch of people down in Northern California beavering away doing exactly that. But that's not particularly part of this .NET story, I think. I think one could do all that very successfully without doing any of this .NET stuff. So it was the .NET stuff we were supposed to be talking about today, right? Not all of Microsoft's approach to life.
Actually,
So I certainly agree that stuff is important. It just seems different.
Yes.
I mean, I could, if there were a reason, I could sit here and explain to you how this fits perfectly into the .NET vision, but I think it really doesn't fit that much. not in the sense that, I mean, some of those things that you describe, I think, are things that are likely to get built on top of the .NET stuff eventually if it's all successful. But I think you could do all the things you said, even if none of this .NET stuff worked, because you could do it just by brute force. It's not that complex. And indeed, that's the way people are doing it today.
And that was the way that, like, the demand trials and set up their server and
Right.
talk to Jesus.
Right, exactly. So if those were the only things we wanted to do, then I think we would not be making this .NET thing the center of the company's vision.
Performance. Currently, the way performance analysis is mostly pretty hard. And then on the services world, where there's no clear border, for example, improve the performance of the network, hardware design is going to be pretty tough. And it's trial and error. Is that another major challenge that we need to address as part of this?
Absolutely, I tried to say that. I think a critical part of this whole deal is that both on your own machine and for all these services and across the network, my story about the aspect of performance that's important is not the aspect where you carefully instrument the thing and figure out how to make it run 5% faster. That's valuable, but that's not critical for this enterprise. What's critical for this enterprise is to have a rough model of how well things are supposed to be working and good enough instrumentation that you can compare how things are going against the rough model. And typically if it's within a factor of 2, it's plenty good enough for this purpose.
Yes.
Because what screws you is when it gets to be off by a factor of 10 or 100, which happens really easily, right? So you have to have a model. It doesn't have to be a precise model. It just has to be in the ballpark. You have to have enough instrumentation that you can compare at a high level, it can compare the behavior of this complicated thing against that rough model. And then you need some strategy by which, having isolated a problem, perhaps you can go down one level, or you can automatically send the thing off to some service organization that will be able to go down one level and apply these same techniques at the next level down. So if I can't make my doctor's appointment, then in a more or less automatic way, you want to be able to find out whether that's because I can't talk to my ISP, or the doctor's service has gone down, or I've got the wrong, the protocol I'm running isn't compatible with his, or something like that. And then you have to be able to more or less automatically, with a minimum amount of human intervention, do something about each one of those things. But I think that's absolutely essential. And it does have a somewhat different flavor than the kind of performance tuning that we've classically done in Microsoft. But I think it's absolutely essential.
Have you ever looked at APE and Vista, the Application Performance Explorer, and Visual Studio Analyzer? These are things we ship.
Mm-hmm.
They're not, the implementations are particularly good, but APE is basically a modeling tool, a system performance modeling tool for modeling distributed systems.
Mm-hmm.
And Vista is an analysis tool for putting instrumentation across your distributed system and collecting data on how it's running.
That sounds like dynamite. So why is it that when I'm sitting on my machine in Cambridge and I'm hooked up over RAS to Exchange, why isn't there an APE/Vista button I can push that will tell me why it is that the thing is running 10 times slower than it was yesterday? Because that's what I want. It's very concrete and straightforward, and it sounds as though with the kinds of tools you're describing, maybe that would be possible.
Yeah, well, we ship them to our customers.
We don't use them ourselves.
We don't use them ourselves. Right.
Well,
PPG doesn't use these tools.
so the concept of dog food doesn't exist for this class of tool.
Right. Yeah. Well, it's sort of like we sell SourceSafe, but we don't use SourceSafe ourselves, right?
My project uses it.
Well,
I don't know how well it works because I don't use it personally. But
I can tell you some things about your project.
I watched our acquisition of. I used to be very interested in this problem when I worked for DEC, and I watched our acquisition of SourceSafe, kind of shaking my head from a distance. It's hard for me to believe that this thing could actually do what we need. And you say it doesn't.
Never did.
And no effort was ever made to do it. It was the kind of mistake that we make over and over, which is that when we decide to build developer tools that we're going to sell, we don't look to ourselves as potential customers. We
Right.
say, oh, the marketplace is mostly these small shops, and they don't care about the things that the NT development team cares about. So we don't have to worry about making the tool robust, scalable,
Well, then that's the reason that this organization exists, right?
That's right.
Is precisely because we have a lot of needs that are different from the needs that the large market has.
Well, it's an arguable case. Would the market really suffer if we had sold a source safe that was scalable and robust?
If you could deliver it just as fast,
Yeah.
and et cetera, et cetera, et cetera.
Which we could have done, and we chose not to invest in doing it. We chose not to spend the money. So.
Well, I'm certainly not going to argue against that because as I say, I worked on this problem myself for quite a while, and it's still dear to my heart.
So
and it's crystal clear that the way SourceSafe does it is not right. So yeah, if you guys want to work on that, that's fabulous. I don't think that directly has anything to do with .NET, but I think it's fabulous.
Actually, John is.
It has something to do with. It has something to do. It does have something to do with .NET in the sense that I think one aspect of this whole how do you do automatic diagnosis thing is you really need to know what software is running. Certainly, you need to be able to know, or your support contractor needs to be able to know what software is running on your machine. And is it the case that the combination of stuff that you got there is plausible? Did anyone ever assemble anything like that before? And quite likely, you might need to be able to ask questions like that for these more ad hoc assemblages of stuff as well.
One of the points that you made was the key thing that we want to achieve is to improve the experience which a person gets on the client machine, like eliminating the installation process and all that. So, can you say something about how the using the software as a service? That's another buzzword which goes on. Can be used to eliminate some of these issues.
Well, I guess fundamentally my view is that those are pretty separate problems.
Okay.
I mean,
my feeling was that if you were using software as a service, then you can completely eliminate the whole installation process, the whole updating process, patching process.
Well, I think you can do that without having the software as a service idea.
Okay.
Because, I'm sorry. Wait a minute. Maybe we're not communicating. What is the phrase "software as a service" supposed to mean?
That You're buying stuff from somewhere. You're buying from over the net.
Okay.
And you're not getting a CD.
Okay,
but you're paying subscription
cool.
from somewhere else.
So let me tell you where I went wrong in understanding your question, because it's likely to come up before. This software as a service is a fine phrase, but it has almost nothing to do with the notion of services over the net instead of web pages.
Yes.
And when I heard the word service, I immediately went down that other path. So that's what we've been talking about, and then I got hopelessly confused. Yes. Well, maybe from a business point of view, from a technical point of view, it seems to me the question of whether I buy Office or rent it is pretty separate from the question of what comes on a CD, what comes over the net, and how automated everything is. Now, from a business point of view, maybe they're not separate at all. But from a technical point of view, in today's world, it seems pretty clear that if I'm going to have anything the size of Office, it probably makes sense to distribute it on a CD to an awful lot of people because the bandwidth's not so great for downloading a couple hundred megabytes. On the other hand, it certainly makes perfect sense that something like, or much better than Windows Update, should exist by which the patches and so on get distributed automatically. So I think there's a bunch of separate issues that need to be teased apart there. There's the question of how do I actually make the best use of the available communications resources, and that may very well involve CDs for bulk transmission of large numbers of megabytes. There's the question of how do I get the thing that's running on my machine to be correctly configured, and how do I get it updated to track the latest improvements and wonderments, and then there's the question of how do I pay for it. And I think those questions need to be dealt with separately.
So, but there's another element of this, which is this notion of your data available anytime, anywhere, right? So in some sense, if you still think of the application as sitting on your desktop, then presumably, unless every time you want to access your data, it has to go across the net. I mean, well, I guess
no, replication's critical.
Yeah. Okay. So there's an issue about sort of where the data is, and I guess that's
Yes.
separated from how the software is delivered.
I think it is fairly separate, although some of the same ideas apply.
I guess it's still the question, right? What are you doing to it? I mean, in some sense, you want, if you're doing a database thing to your database, then presumably you want all that stuff to be happening on some large server, right? So I mean, there's.
Well, not necessarily. In fact, I may very well be able to want to be able to do that in a disconnected way and have the server updated the next time I connect.
Right. Yeah.
And today we actually do that pretty well in one domain. It's almost the only thing that Outlook does well. And I've discovered, in fact, that it's much pleasanter to run Outlook in disconnected mode, because then everything's local, everything's fast. You never have to wait for the server. The only downside of it is you have to push the synchronize button every now and then. And Outlook 2000 even has the property that it can do most of the synchronization in the background. It's about the only thing it knows how to do in the background. By the way, do you guys know the story of that? Apparently, 2 or 3 people have told me this now. Apparently, originally Outlook was designed with all kinds of threads and asynchrony and so on, but they didn't understand locking at all. And so when they started to try to debug the thing, they discovered that it didn't work. And the only way they could figure out to get it to work was to take out all the concurrency. I thought it was pretty awful. But it's pretty consistent with the general image that Outlook projects, in my opinion.
I'll tell you what I find more frightening. My experience is that that's not applicable. That 50% of the developers
don't understand locking. And we have all these crazy threading models and things which I can't understand at all. So it's not surprising to me that the developers get confused.
So that leads to a real question. It seems that every time we try to introduce a new programming model and make things substantially more complex, because we can never completely discharge the old programming model. How do we avoid that problem? Or is that just that we've got smart people in the room figuring that?
How are we going to keep from making things more complex again? Well, that's a very interesting question, actually, and I don't know the answer, but I think there's some chance that things are going to become simpler in at least some ways. If you actually, I'm not sure whether I do believe in this, but in the short run anyway, but certainly in the long run, I believe that the set of ideas that are represented by the URT, the notion that there should actually be reasonably strong type checking and a reasonably safe language so you can have garbage collection and stuff like that are bound to win out. And that is going to help. That's good. You're going to remove one sizable class of problems. And it's also going to create a lot of incompatibility, which is going to remove another sizable class of problems, because a bunch of aspirations that you might have had for making X compatible with old Y are going to be impossible. So you're going to have to abandon old Y. Now, people haven't come to grips with this yet. Now you hear this babble about managed C++ and stuff that, in my opinion, can't possibly work. But those things are, they're actually not going to work. So they're going to die. We're going to waste a lot of energy on it, but eventually they're going to die out. And we're going to have a somewhat cleaner world in which most programs are written in a safe language and are garbage collected and so forth. And that's not going to be problem-free, but it is going to be substantially better.
And also, for example, to the extent that the URT talks a little bit about the thread model that helps to standardize everything enough.
Yes, right.
And also very local about what happens on your machine.
Yes, this was a very local question, I thought.
Right.
This question was somewhat unrelated to the grand .NET questions, except in the sense that .NET adds a bunch of new stuff.
Right, exactly.
Right.
You want to achieve more without increasing complexity.
Yes. Yes.
But do you think this sort of leads to another question? If you have this enormous complicated .NET system with the pool of tens of thousands of programmers, at least half of whom are below average, then is there?
I thought Microsoft didn't hire any below average programmers.
Well, everyone is above average,
But just the contractors were using
way down there. Is there one of the ways that you make this kind of system work is like everybody working on it being extremely smart and clever and always doing the right thing. Since that's not going to happen.
Yes.
Is there anything we can say about how like structure either the process of running the system or the system itself, so that it's more likely not to just fall apart? I'm not sure there's anything clever to say about that, but that's...
Well, yeah, I think there are well-established disciplines that have been proven to work. Go back 20 years. In 1981, Xerox shipped a product called Star, which was an office automation system, which was not particularly successful commercially, but it was actually the best office automation system in the world, certainly from the point of view of functionality and user interface for 10 or 15 years. And this system, I was working for Xerox at the time, although not in the development organization. I was in the research lab. The development guys were just across the street, or a lot of them were. And this system had the following properties. It was about 1/3 of a million lines of code, which was a pretty big system for 1981. It took about 4 or 5 years to build. It was built by a bunch of about 50 people who were basically hired off the street. I mean, not stupidly hired, but this wasn't a group with that had been working together for a long time and so forth. And although there was a very careful and high quality and well thought through design for the user interface, there was no such design for the implementation. So I was looking the system over about 9 months before they shipped it, and I said, any system that has these 4 properties has a 5th property too, which is that it doesn't work. And there's some pretty fundamental reasons for that. So I predicted they wouldn't be able to ship, because I predicted they would not be able to make it reliable enough. And I was wrong. They did ship, and Star had several problems. It was too expensive and it was too slow, but reliability was not one of them. Reliability was okay. So I was reflecting afterwards on how it was that this happened, and I'm pretty convinced that the reason it happened was that Star was programmed in Mesa, which was a language that, although it did not have garbage collection, did have strong typing and a very strong notion of interfaces. And the whole group that did the implementation really signed on to that. They didn't fight it, as people often do. And I'm pretty sure that that was the reason that they were actually able to get the thing to work. So that's just one of many examples, I think, that show that you know, if you sign up for the discipline of dividing things up into suitable sized chunks and having interfaces that are religiously obeyed and so forth, and you put your heart into it, it can help a huge amount.
But in hindsight, wasn't that the reason you failed? If you had any design checks at the time, it made it not so reliable, but performed better.
No, then it wouldn't have worked at all. No, we could have a separate discussion about why it failed, but it wasn't for that reason. There was an interesting thing that happened later, actually, which was an illustration of the fact that whenever you get a new tool, it can do great things for you. It can also cut off your fingers. They found a couple years later that it was very difficult for them to do new releases. And it turned out one of the reasons for this was that because this interface stuff was so great, people were quite fearless about importing a lot of interfaces, because they felt confident that the compiler would keep you. If they'd been programming in C, they wouldn't have dared to do this, because they would have known that it wouldn't work. They felt quite confident that the compiler and all the interface checking and stuff would keep them out of trouble, as indeed it did. But now the problem was, if you wanted to change one of these interfaces, it was being used in a lot more places within the system than it normally would have been. And of course, the compiler would point out all the places where, or the linker would point out all the places where it was being used for you. But you actually had to go to all those people and get them to change too. And that was hard. So that was sort of an interesting observation, that even when you have this wonderful stuff, you still have to think fairly carefully about how widely the dependency net is spread.
So one thing that Philippe and I have seen when we talked to a few places is they really like the individual basic tools that Microsoft's making available for all this web stuff. And they said, gee, it's great, we'll get off the ground in a week, and life is wonderful for about 6 months. And then we have to throw it all out because the performance of this stuff can't handle the load. And it's like falling off a cliff, because there's no support then for sort of figuring out, A, what's performing poorly, let alone figuring out how to rewrite some of it incrementally as compared to just starting over in C and writing, awful low-level stuff. Is there anything we can do about that?
Well, presumably there's a lot we can do to make it.
Okay. I guess my question is, I'm bringing this up and asking, what kinds of things should people like us be doing about it?
Well, it seems like the big issue from the point of view of tools is to make sure that it's possible to figure out where the performance problems are.
Are there any changes in things like programming models that need to be considered, or is it mostly a matter that we can help with doing performance analysis?
No, I think actually, I assume the people that are unhappy are people that are trying to run websites.
Yes.
Right. Right. I think there is a structural thing, which is there's a pretty well-established discipline for how to build a scalable website, and it's got to do with doing partitioning and making it many things as possible stateless. And we could go through it if you want, but you probably know that. And to the extent that the world is set up so that it's easy for people to build their code so that it fits within that methodology, and hard for them to, and easy for them to find out when they've screwed up in fitting within that methodology, then you can solve a lot of your problems by just buying more boxes. And to the extent that we're successful with the server side of my client-side story about making it so that you can install and manage lots of boxes without consuming too many people, that's an extremely cost-effective thing to do, because boxes are not that expensive, and high-bandwidth network connections for them are not that expensive, and so forth. And so, yeah, it may well be that 5 or 10 times as many cycles are being consumed as would have been consumed if you'd done the thing in a careful, highly tuned way. It's probably a good deal. So I guess there's two answers to your question. One is the methodological one of how do you make it, what can tools or whatever do to help make sure that you've actually written your program in such a way that you can apply these techniques. And two, doing on the server side the same stuff I was talking about doing on the client side.
Do you think it's a mistake for them to be using things like Visual Basic, given your experience with type-safe languages for things like this stuff?
Well, the theory of Visual Studio 7 is that these things are supposed to be a lot less different than they have been historically. And given that, I don't see a problem. And it seems to me extremely plausible that I should be able to, probably not next year, but within maybe 3 years, I should be able to write my server stuff and run it in the URT, and it should be okay. And I shouldn't end up paying more than 50% for having decided to do that. And that should be a bargain.
I think that's back to what you said about ASAP. In theory, it's possible, but in any language, you either buy into the language philosophy or you continue to do it the same way that you always have. So Visual Studio is going to make it, my guess is, will continue to make it possible to write raw Visual Basic, raw JScript, all these non-C, all these non-type-safe languages. Is this something that you need to be moving people away from?
Absolutely.
Yeah.
For sure.
So, I think the basic question that we have is sort of about the tools and the performance and the systems. But we keep coming back to programming model until we can say, well, here's the programming model for this thing, this .NET, then it's pretty hard to have anything more than sort of abstract discussions. So you said like XML and transactions, but what in your mind are sort of the key components of the programming model? We focused a little bit on sort of what I think of as underlying support languages. I mean, I don't think of Java anymore as a high-level language. I think of it as a given low-level language for expressing what goes on, on some virtual machine. And I take type safety and all that good stuff, and some motherhood and apple pie, we're going to do. But there's a lot left unsaid, which is, what is the programming model for .NET? How are people really going to think about this thing? What's going to be different? And really, what are the problems? So Luca Cardelli had a paper that sort of talked about, programming in that. He said, well, you're going to have to, all of a sudden, connections, time is going to be important because things might time out. You might connect to a service. You might have several different backups you can go to. You have to start thinking about these things. So what in your opinion are sort of the main problems that have to be addressed in .NET, and what do we have? Like, you said XML and transactions, but...
Well, I think there's a couple things to say about that. One of them is a fairly conservative thing, which is, okay, we could go on writing our programs more or less the way we write them today, with doing RPC to remote services. And it's certainly well known how to engineer a remote service, a service with an RPC interface, so that it can, for example, automatically fail over from one machine to another, so that the programmer doesn't have to worry about that. And it's clear that we should be doing those things. The way I like to, the really concrete way I like to think about this is, one of the things we should be doing is we should be really making clusters work. And what that means to me is that it is okay. You walk up to a cluster with 4 nodes. It is okay to unplug one of them. The operations guys will not say, ah, if you do that. So what that means is that the failover really has to work without disrupting the clients.
It's also not visible to the program because the
Correct.
system takes care of it.
Correct. And so what that means, I think the way you implement that is there's some low-level things, like, for instance, the database, that actually have to be aware of the failover, and there has to be code in there that does the right thing. And then the higher-level stuff should not even notice. I'm doing my RPCs to the cluster. Perhaps there's a transaction that gets aborted and gets retried or whatever, but the high-level stuff will not even notice. And there's a large class of applications that we know very well how to code that way. Now, the clusters we have today definitely don't have this property, and I don't think we're well focused on achieving this, but I think this is something that's really important. Now, I can give you a more complicated, a different kind of answer to your question, which is much more speculative. Although this is definitely something that people are working on too. And it goes under, usually it goes under the rubric of loosely coupled computing. And that means a lot of different things, but I'll tell you what I mean by it. The way I like to think about it is that if you want to have a really network-oriented computation, the way to build it is to think like this. I'm going to have a persistent thread, and the way I'm going to make the persistent thread practical is the following. The thread can call a procedure on some machine and can do more or less arbitrary things inside of that procedure. They can call lots of other procedures and do all kinds of complicated local stuff. If it wants to go to another machine, the only way to do that is to return to the top level, package the state of the thread up in a message, and put it in a persistent messaging system that will send it on to the next machine. And there are actually quite a lot of commercial systems that are built this way, more or less by hand, using products like Microsoft's MSMQ or IBM's MQ series.
You've got Tuxedo and other transactions who've already done that.
Yeah, people have done this. Transaction monitors by themselves don't do this, but
no, but through the message queue and the
that's right.
transaction processor, we were able to tell this go to the other machine.
Right.
Even to the client was the same.
Exactly.
So really what we're talking about, systems already developed, but at a larger scale.
Yes.
I mean, it's nothing new.
Yes, this is not a new idea, although applying it in a making it your religion for programming is somewhat new.
So yes, but in the enterprise, there's always people. That's why we've done that.
Quite a lot of people have done this. That's absolutely right.
So this is it's sort of akin to like an event loop in a Windows system that you get events at the top level in dispatch, but you don't sort of handle events when you're lower down.
Well,
that all the communication takes place at some central point, and then you let local computation proceed, and then you sort of come back whenever you need to do communication.
Well, that is a consequence, but that's not the way I like to think about it. The way I like to think about it is the way I described it, which is that
well,
I should think of my...
You come back to the top level. Whenever you need to communicate, you must come back to the top level, package up some message, and send it off. You're not allowed to do it at the lower level.
Right.
Packaging out the closure, as it were, so it's not.
In principle, you could implement this religion by saying, okay, suppose I'm 12 levels deep in procedures, and I want to communicate. In principle, I could implement this religion by saying, okay, as John says, there's 12 levels worth of stack frames. Let's bundle all that stuff up in a message, and now we can send that off. And when it comes back, we can reinstantiate all those stack frames and keep running. I don't think that's practical, because there are far too many local dependencies. So, in fact, if you want to realistically program within this framework, you have to adopt the discipline that I said, which is that you have fairly well-defined message formats, and you have to be able to code all your state into the message formats. And this has a number of advantages. It means that quite likely the thing can still work even if it comes back to a new version of the software tomorrow, as long as that new version is written to run against the same message formats. It also means that while the threads are sitting in these so-called message queues, I think of them as thread queues because of the twist that I gave on this programming model. You can write schedulers that go in there and look at the state, since the state is it's not just a whole bunch of local variables. It's been forced into the straitjacket of reasonably well-defined message formats. You can look into the state of these threads and make scheduling decisions based on it. So you have a lot more flexibility about how to reorganize the way your computing resources are brought to bear to get the job done. And I think this is a very powerful programming model and is likely to have a big effect.
I agree. The consistent message format, because one of the things we usually use to call AMF, ASCII message formats. Basically, that's how we incorporate the different transaction and service. Basically, all of them understand how to parse these ASCII message formats, but we don't care how the implementation works. And surprisingly, right now we are advocating XML. My concern with XML is that for our message format, we limited the text to 3 characters. Now we are talking about text that could be self-defined, and the performance hit from those type of.
So it'll be too inefficient.
Yeah, to really translate in between the server and the client. And that's my concern is that because we tried differently, and we decided 3 characters and that's it. And we had messages all like one string that's coming back, between the server and the client. But now we're talking about messages like 10,000, considering the 100 characters we used to before. So I'm not sure how we're going to solve those issues. This is going to continue unless the bandwidth is so big.
So there's certainly some performance issues, and there's some techniques that could very well be applied to make things better. Some simple-minded compression, for instance, might help a lot.
That's what I was thinking. I mean, if you're on the server side, if you get some kind of compression, the client side, we decompress those things. We might have a better performance than what you're trying to think. Just send it back, ASCII messages.
Right, and then you wouldn't have to change the architecture at all.
Yes. And one other question, so with respect to the net services, one of the confusions I have right now when listening to the presentation is that we are going to provide services in the software. It says people will pay monthly, and get all the services from us. My confusion is that what do we exactly need? Because right now we're still talking about the client where people are still using Word, still using all the stuff, and we have other people, corporations going to buy also server, applications. So actually we're going to continue to develop the Windows 2K, Windows 2002, and et cetera. So what is really the service?
How does all this fit together?
Sorry?
How does all this fit together?
Yeah.
Well, I don't think we really know the answer to that question. Let me just suggest one aspect of it. If you look at the way we sell Office today, probably half of our Office business really is a service business, in the sense that people buy it on site license, and they get an update once a year or once every 6 months or whatever, and they're not really. It's difficult to distinguish that from a software service business. So we definitely have already been moving in that direction. Now, if your question is Microsoft going to go out of the business of selling packaged software? I doubt it.
That's the thing. I mean, it doesn't seem like we're getting out of it.
I doubt that we're going to go out of that business, but I do think you'll see a shift.
I mean, why should we go? No, we still sell dogs. I mean, we do. No, $150 million a year. It's
yeah, but I can see corporations.
Looking forward, the thing that has created some confusion is we talk a lot about software as a service, but we also need to remember that we have this emphasis on keeping the client a very rich client. We don't want to.
That's not incompatible with software as a service. Software as a service does not mean that all the work is done on the server.
We're going to have worse problems than ever with the kinds of things that were in the paper that we handed around from Butler to read about PCO, in that we want a world in which you have less control in some ways over how software gets updated and upgraded on your client. And people are paying us money in order to have that service, whereas today we're running into a lot of resistance from people who don't want to change anything on their client because they don't trust us. They don't believe that we can do it in a way that will work. So that's a real challenge that we've had in this world.
Let me just a little bit and ask about some of the traditional distributed systems issues that security authentication, so forth. Do we know enough to actually build these kind of systems?
We know far too much. I'm very concerned about the security problems, and the reason I'm concerned is not because we don't know enough. It's because we have no process in this company for dealing with security. We have an immense amount of knowledge, but we have no process for bringing the knowledge to bear effectively. And we are probably, all organizations have this problem, but we have it more than most. The instinct of people who work on security is to make things more complicated. And we've done a fabulous job. Things are so complicated that last time, 3 weeks ago, I spent 3 hours in a room with half a dozen of the NT Group's security experts. And they were trying to explain to me their scheme for cross-forest authentication. Most of the time was spent with these 6 guys arguing with each other about what it was they were planning to do. Because the whole thing was so complicated. They had made it so complicated they could not even communicate with each other. Is it necessary for it to be this complicated? No. Are we going to find a way to make it simpler? I see no evidence of it. No, this is a terrible problem. Fortunately, this is not a problem for you guys. But this is a very serious problem, and I firmly believe the problem is not that we don't know what to do, that we don't have enough knowledge to do something effective. The problem is that we don't have a culture and a process for bringing that knowledge to bear effectively. Just one tiny example, which is actually quite tangential to the central issue, but I don't know how many of you know that when we shipped PPTP, the encryption scheme that allows you to do RAS securely over the internet, the code that we shipped had the property that if you used the same password, you got the same encryption session key, which effectively makes the cryptography useless against anyone except a high school student. Now, how did that happen? It's certainly not because Microsoft doesn't employ cryptographers that know better. We employ lots of people like that. Okay? It didn't happen because there's something wrong with the process by which the whole thing got done. Okay? But that's an amusing example, and it's illustrative in a sense, but it doesn't get to the heart of the issue, which is that things are too goddamn complicated.
So how much of it is the design process around here, or the Mac design process? How much of it is the cowboy implementations?
Well, I think the fundamental problem in security is 2 things. One of them is historical. There's a tremendous desire to be compatible with a whole bunch of stuff. And to some extent, I think, actually, if you want to have security, you're going to have to give that up. And you're just going to have to say, I'm really sorry, guys. You have all this old stuff, and we don't know how to secure it. We can't solve that problem for you. Or we can only solve it in a way that won't actually work. What that means is if you've got every single bit of the configuration information set exactly correctly and kept it that way, it would work. But you'll never be able to do that, so it actually won't work.
But you won't be any worse off than you are.
You won't be any worse off than you are now. That's true. But that adds a tremendous amount of noise to the process. But the other thing, which I think is even more important, is security is fractal. I mean, you look at any part of it, it's just as complicated as the whole. And you look at any part of that, and it's just as complicated as the whole. You can always go deeper. Okay? And that's what security people like to do. And whether they're our security people or our customer security people, that's what they like to do. So the instinct is always to add another piece of mechanism to solve another problem. And what people lose sight of is the fact that the fundamental difficulty with security, and this is my personal opinion, I've worked on security a fair amount off and on for the last 30 years. The fundamental problem with security is administration. You can't get the pile of stuff that says who is supposed to be allowed to do what. You can't get it set correctly. And in our world, my machine at home on which I run Win2K server, I have a little SonicWall firewall box because although I know that it's possible to configure Win2K server in such a way that it would be reasonably secure when hooked up to a cable modem, I have absolutely no idea how to do that. And I'm reasonably certain that there is no 50 pages I could read that would tell me how to do it. I haven't actually tried to do this for Win2K, but I did try fairly hard to do it for NT4.
I tried, so I ended up buying firewall too.
So this is crazy, right? We can't have this, but we do have it. This is what we have. So every time I talk to the security people, I say that the only really important thing for you guys to do is you need to be able to write a 100-page document that tells the ordinary person, or ordinary 50 or 100 machine organization, how to configure things so that it will be secure. And that document may include messages that they don't want to hear of the form, I'm sorry, we can't do it for NetWare, or I'm sorry, but you can't have the degree of fine-grained control that someone has imagined you might like to have over something or other. But at least there'll only be 100 pages to read, and if they follow the 100 pages, it'll work. And we're just infinitely far away from that. So, yeah, this is a big problem. Fortunately, it's not your problem.
Well, the modeling aspect and some sort of diagnostic aspect could be.
That's possible. It is possible. It is possible.
It's not just the tendency to trace mechanisms, it's the practice to deploy new mechanisms.
Yes. Oh, yes. New stuff all the time.
Exchange 2000 is bringing new kinds of security principles into the game. It's brand new. And we just keep doing it. We have examples every time we evolution.
Yes, and the URT has its own security model, completely different from everybody else's. And it's actually not as different as it looks, but they think it's different, and the NT guys think it's different. So for practical purposes, it's different.
So the docs would definitely make it look different.
Absolutely. And my view is they shouldn't have been allowed to do that, and there was no necessity for them to do that. But
I think another way to possibly our problem is about the whole question of does the implementation adhere to the rules that it's supposed to?
Well, that's a significant question, but in my view, that question is extremely secondary to the questions that we've been discussing. That's the thing that people like to focus on is, are there bugs? And there's no question there's bugs. There's thousands of bugs.
So it's not even the bugs as the exploitable overflows per se. It's making sure that people implementing the framework for the system are not putting the unexpected backdoors in front. I don't mean intentional backdoors. I mean it'll be convenient for people to double click on something and be able to edit it. Thus, I will take advantage of the security model in such a way to enable that as a default. I think a lot of it's education, just making sure that people, programmers, think of this as they're doing the design and implementation of the system. But I also think it's possible to instrument this, to detect problems related to this. True, not without an overall security model in place, but even once there's a security model in place, I don't think that solves the problem.
Yeah, you're probably right. But today I don't think there's much you could do.
So I have a question about the programming model. It goes back to your point about him dealing with failure very well. So that makes sense in a situation where you've got clusters and you've got people administering them. But if you've got the website that has the travel.
Oh no, I don't want anyone administering the cluster. Got to do it automatically.
So that works in the case where you've got somebody offering a service that's pretty well supported, basically, as well as they're willing to build a cluster to support it. So, but what about the individual who has a service in their home or whatever, and they're providing it to other people? If I'm a user of that service, right, and I'm writing software, I can't assume that there's going to be some kind of failover from it. So the fact that it might not be there is something that has to be exposed in my software environment, right?
So to the extent that you sign up for this so-called loosely coupled style of computing that we were discussing earlier, it'll be fine because your request will go into a persistent queue someplace, and if he's down, it'll sit there until he comes up.
I see. Okay. So that's
your thread's persistent.
I have to use that model to build my software no matter what.
Well, that is a very good model to use, and it's an especially good model in situations where you think the connectivity or the upness is not going to be very good.
Right.
If you're talking to people that can afford to run clusters and have 2 different ISPs and so forth, it's much less necessary to use that model. Because then the probability that they're up is much higher.
It seems like the fact that it's not there still has to be exposed somehow, because I, as a user, may not want it to go in some queue and wait, because then I won't get a response, right? I may say, well, yeah. So it seems like the You know, the fact
Well,
that
in
it
that
comes
case,
out
it'll come back 404.
Yeah, right. Right. So, but I mean, that's the point. I think in some
Well, there's nothing we can do about that.
Yeah, it becomes a difficult problem no matter what.
Although there is actually another story about that, which is, and now I'm telling you an extremely speculative theory. You've probably heard of workflow. Nobody really knows what workflow means as far as I can tell. So I will tell you what it means. Okay. What it means is you're going to program in this style. And at the top level, the program you write at the top level is going to be the workflow. So the program you write at the top level is going to say, you visit this site and do this operation, and then if it came back true, you go to this site and do this, and if it came back false, you go over there and do that, and so forth. And you're going to write a top-level program that includes as much as you understand about how the whole workflow process is supposed to work. And if you, and one of the things that program is going to have in it is places where it says, you know, go talk to so-and-so and show him this form because I'm confused. And by working harder, you can add more lines to the program and reduce the number of times that we'll have to do that. And that's the basic story about how workflow should work. And you know, a lot of people think workflow is about boxes and arrows and so forth. Well, you and I know that boxes and arrows are just a bad programming language. And there's nothing wrong with having boxes and arrows for situations where the diagram doesn't get too complicated or if it makes people feel good. But fundamentally, you're talking about a programming language. And what workflow is it's a program. And you're writing the program at this very high level where everything is persistent and everything is transactional and so forth, which doesn't mean that everything is going to work, but it means that large classes of errors have been subsumed underneath the umbrella of persistence and transactionality. So an aspect of this that I didn't mention is that's very important is when one of these messages actually visits, when one of these threads actually visits a site, you run a transaction under which you take the message off the input queue, you do all the work and update any permanent local state at the site, and you put any resulting messages on the output queues. You do all that under one transaction. So if anything goes wrong, the thing's still sitting on the input queue.
One problem with this approach is that the workflow at the top level can't be too complex, otherwise you just you run into tradition problems.
Well, it can be as complex as you want to make it. In some situations, it might pay to make it quite complex.
Right, but if you can't decompose things hierarchically, for example, you have another workflows, maybe a misunderstanding of step on another machine, which is a sub-workflow, let's say. You don't have that mechanism, then you have to do everything in like a main program.
Yeah, there are some issues about how to make this story modular, and I haven't thought deeply about that, so I don't really know what the answers to some of those questions are.
My understanding is you do everything in traditional main loop or main program, right?
At the top level, that was the way I explained it, right? And I don't have a good story about how to get around that, although I'm sure there is one.
So let me ask another direction, which is that a lot of the stuff that interfaces in XML do are sort of what I call syntax. Basically the way things look. You get the right number of arguments and the right type. But they don't talk about the semantics of operations. And XML has exactly the same problem,
right,
which is, why schemas are only a partial solution to exchanging information. So how important is it to actually go the next step and trying to capture the semantics so that we can exchange information and know what it means?
Well, my theory about this is that it's very important, and we have a well-developed technology, at least at the level of theory, for doing that. It's called writing specifications, and we know how to write good specifications for arbitrary services, and you know how to do correctness proofs. And that technology has been worked out over the last 15 years, and it's really good. It hasn't been applied very widely.
When you say that technology, who's working?
I'm talking about the work of people like Leslie Lamport and Nancy Lynch, and lots of other people more recently. But that stuff really works well. 15 years ago, if you'd asked me this question, I would have said, "Gosh, I don't really know." But I wouldn't say that today. You give me a problem, and I'll show you how to write a spec, and I'll show you. You give me an implementation, I'll show you at least in principle how to do the correctness proof. You might not actually be able to carry out all the details because it might be too much work, but there won't be any problem of principle. Now, how to bring this to bear on building real systems is unclear. Programmers are very resistant to doing this.
Well, what I was going to ask is, do you think those techniques really work for real systems with
Yes.
sort of real-world complexity as opposed to sort of well-chosen examples?
Yes, I do. And I think the right way to say this. The key to success in playing this game is that the specs have to be non-deterministic, even though the actual code may be deterministic. And I think the way you deal with the real-world complexity fundamentally is to, when you write the spec, you say, if under certain conditions, the results, I'm not going to tell you exactly what the results are. All I'm going to tell you is that they fall within this space. And that might not be all. You might prefer to have more information, and in fact, more information might be available, but it's too hard to write it down. You can still make a lot of progress.
So personal specifications are better than not.
Absolutely, absolutely. And I think the biggest problem, in fact, that people have had in writing specifications is they've been too compulsive. And then what you find is too much work. And so you back off from that to doing nothing. I think it's a bad deal. There's an interesting project going on in Microsoft Research, in Yuri Gurvich's group. They're building this. You heard about this? Were you there when he was giving a spiel? Okay. I don't know whether that's going to work or not, but I think it's certainly worth looking at. Because what they've done is they've devised a pretty high-level language for writing these specs, and they actually have an implementation that lets you run the specs. And you can turn a spec into a COM object, so you can actually put a system together that's partly spec and partly real code, as long as it splits along COM interfaces. And it might work really well. So to just back up and repeat my original answer to your question, I think I only know one way to address this problem, and my intuition says that it's feasible to address it this way, but it is very, very countercultural for almost all programmers, not just Microsoft programmers. It's a real challenge to have specs that pass what Dave Pond has called the coffee stain test. He was writing within the context of government projects, where government projects have requirements documents, usually several volumes of them. And he said, for a requirements document to be useful, it has to pass the coffee stain test. And what that means is you go into the office of the implementers, and you ask to see their copy of the requirements document. And if it has coffee stains on it, then it's doing some good. And if it's sitting pristine on the shelf, then it was a waste of time to write it.
So not just on the cover, but on the inside page.
And that's a challenge.
One thing that terrifies me about this is, I think it's in '82, I went to the 10th World Computer Congress, and Jackson stood up and told us that we'd all be programming in sort of 5 or 6 languages within 5 years, and it'd be a mixture of, well-known languages. And I've had various other cases where that's gone on. I also used to live in Europe as well, and where I'm driving with this is that there's a sort of story about the Tower of Babel that argues that different languages are recursive God, and I sort of almost feel that that's true. I mean, whenever you've got different cultures and languages and idioms, that things get so complicated so fast that your brain explodes. You just can't manage it. So I'm just wondering, are we really going to overcome this? Or is it just going to be another disaster?
Well, yes and no is the answer. Is it going to be another disaster? My view is that the history of the development of software has been a series of triumphs. I don't see disaster. I mean, yeah, lots of things go wrong, but we can do enormously more today than we could do 10 years ago, and we could do enormously more 10 years ago than we could do 20 years ago, and so on. And so we're making great progress. I don't understand why everybody's so negative. Everybody talks about the software crisis. Well, I'll tell you why there's a software crisis. It's very simple. It's because computers can do anything, And so and what's the limit? The limit is our ability to write the software. So naturally, we're always going to have a software crisis because we're always going to be trying to do a little bit more than we can. And no matter how much you improve things, you're not going to change that because it's going to make it possible to do more things. This is good. This is not bad. If we looked back over the last 10 years and we said, gosh, you know, if I want to build a system today, I'm really no better off. I can't build it any faster or any better than I could 10 years ago. Then there'd be a reason to feel bad, but that's clearly not true. We can do lots more today than we could do 10 years ago.
Although we seem to spend all our time reinventing the wheel.
Well, that's...
Have operating systems really got any better in the last 20 years?
That's not an interesting... That's like asking, has floating point addition got better in the last 20 years? I mean, the idea of what an operating system is has changed enormously in the last 20 years. And is it better? Yes, I think it's much better. I have a talk that I give about software components, where I say basically software components can't work. Now, the dream of software components is there's going to be this library of thousands of components, and when I want to build my system, I go to the library card catalog and I futz through it, and I go to the shelf and I pull down 20 or 30 or 50 components and I plug them together and I write a little bit of my code. This dream, as far as I can tell, dates back to Doug McElroy in 1968, and it's never worked. The only time it's ever come even a little bit close to working is with Unix pipes and filters. But basically, it's never worked. And my belief is it never will work. And the fundamental reason it won't work is because there's no business model for components. And the reason there's no business model is that all the evidence I've ever seen says that the difference between building a reusable component and building a module that does the same job in the system that you are building is at least a factor of 3. And nobody will pay for it. So that's why it doesn't work. On the other hand,
by the time they do, it's obsolete.
That's a separate question. They won't pay for it. On the other hand, components have been a huge success. It's just the component is Oracle. The components are huge, and I don't take 30 of them off the shelf. I take 3. Right? I take IE and Oracle and SAP and Win2K, and I can put my system together out of those things, and it's fabulous. I mean, there are lots of problems, but and it's absolutely true that I only execute 5% of the instructions that I bought, but nonetheless, I can get my system built much, much faster than I used to be able to do. And yes, it's true that it consumes 10 or 50 times as much in the way of hardware resources as it would have done if I had carefully crafted something to do the job. That's completely irrelevant. So in that sense, components have been a huge success. And that's probably actually the biggest contributor over the last 10 or 15 years to why we've made progress in software.
Actually, I had another. I'm still going back to my programs being shipped on CDs.
Yes.
Before when you had floppies, people worked really hard to make sure that programs fit on the floppy. So they really carefully made sure that it didn't exceed the capacity of the floppy.
Yes.
When the CDs came in, then because you could ram in, a few hundred megabytes of stuff there, people ran the stuff out there.
Mm-hmm.
But even if you look at Office or any of our products right now, which are there, there's the essential part, the core part, or the actual part which is needed is really very small.
Mm-hmm.
So if you're going into this whole internet completely connected environment and things like that are there, why shouldn't we be completely rethinking how we package or what we, if you
Maybe.
look at, because then, you really essentially need a very small portion of the programs that are being shipped on the CDs, and that may be a way to sort of like go back and really improve the user experience, because
I don't see how that helps me with the user experience. If I get the CD in the mail and I drop it in my CD reader and the right thing happens, I'm happy.
But then you are responsible for updating it.
No.
You're responsible for pressing the install button and everything. That I don't just want to click on an icon and get the thing running on my machine without having to worry about.
So I click on the icon and it says, please put in the CD that you got in the mail. What's wrong with that?
But that's okay for this CD.
Mm-hmm.
But when an upgrade comes in, then you have to go back, stick another CD in, rather than say you have Microsoft Investor or something like that.
Well, if the upgrade is small enough, I definitely think the stuff should be delivered over the net if there's enough bandwidth. Okay. No question about it. And all of the infrastructure for doing the installation should be the same, whether the bits come over the net whether they come over the CD. All I'm saying is I don't think we should get hung up and say we're only going to do it over the net, because that's going to stop us from applying the technology in a lot of situations where it can work fine.
No, but if you look at the size of the applications which are there right now.
You're saying we should write smaller apps.
No, or we should partition it in a certain way that we get it, because then you can still use, because right now it's not practical to do it over the net.
All right. Well, I just don't think that's important. I'm sorry. There are a lot of, if you go to the office guys and say, start doing that, that's going to add a lot of noise to the process, and it's not going to pay off, in my opinion. I think it's okay if the bits have to come on a CD. I don't see that as a major problem, as long as things are engineered in such a way that, from the user's point of view, it doesn't make it. The user's only job is to drop the CD in the tray.
So that, for example, if someone is supporting this PC from elsewhere, they can tell things like how many times have you dropped the CD in the tray, and which version are you up to, and so on.
Absolutely.
And
Just as they could have done if I downloaded it over the net.
Yes, exactly.
But how the bits are actually transported, it seems to me, is a question you want to abstract out. Because you don't want to put yourself in a situation where you have all this wonderful structure for running the user's PC, but it only works if the guy's got a 5 megabit connection. Or it only works if the application guy happens to have been able to squeeze his app down to 1.5 megabytes. Because there's no reason for that. It can work perfectly well, even if you don't have those things.
Although
that's not what they have today, by the way. I was absolutely horrified. I mean, Office has this wonderful installer thing, and I was having some trouble with my Office, so I pushed the button that said verify or whatever it is, and I happened to I was doing this over my PPTP connection. I had the monitoring turned on. It transferred 120 megabytes. Now, that's ridiculous. There's no reason for that, right? It should have transferred a few hashes. I do believe it's good when it does that it should have checked that I have the correct bits. But obviously it should have done that by hashing the bits that I have and transferring those. So that was just nuts. And I have absolutely no idea what it was doing. It was clearly the wrong thing.
Well, so this is a question that's related to that, which is, here we are, right? And you're saying basically what we need are these systems that give us kind of a rough estimate of what they should be doing. And verify that they're doing that if they don't tell us. Okay, so how do we get from here to there? I mean, how do we make any progress given the realities of this company to sort of get to that vision? I mean, I think we're as a group, we're sort of locked into this notion that that's a really good idea. I personally totally agree with you.
Mm-hmm.
So, but I don't see necessarily any kind of obvious steps that can be taken to move toward that, or how to especially to get buy-in in terms of the next generation of products and things along those lines. So do you have any thoughts along that?
Well, my vague thoughts are that I don't really know whether this is practical or not, but it seems to me it ought to be possible, since we have this world where even in backward Microsoft, people do, as far as I can tell, tend to build applications out of applications with common interfaces. It should be possible to take advantage of that, to make it possible to build your model for how the thing's supposed to work based on the COM decomposition, and then instrument those COM interfaces in the right places. And that way, make it so that you're not asking the developers to change their way of life. All you're asking them for is to understand enough about how their app is supposed to be working to be able to build these models. So, and the way I would approach that is that I would pick 2 or 3 plausible sounding apps, and I would go and actually try to do that at some high level and see what goes wrong. And I've been very impressed by the fact, for example, by some of the work that Galen Hunt did, where he has this crazy system where he can take an app built out of COM components and actually automatically distribute it. So he instruments all the interfaces and he counts how many bytes are flowing across them, and then he tears the thing apart and plunks some of the components down here and some there and puts in stubs and stuff. That's probably not very practical, but the fact that the app still works after you've done that means, I think, that COM is really working well. And that seems to me that gives us a tremendous amount of leverage to do things that are much more conservative than what Galen did.
Is that really true at the overall system and distributed system level? So SAP and Oracle, for example, are
Well, they're communicating with the web server through HTTP, presumably. So you might have to instrument that too. That's probably easier.
Okay, so focus on the communication between the two of them.
Well, it's an interesting question what form these models ought to take, and I don't know the answer to that question. I don't know any way to find out except to try it a few times. But the error that we're likely to make, I would say, is to make them too detailed. I vote for making them very coarse. And you only want my idea is get within a factor of 2, because the things that are really bad are where it's wrong by more than a factor of 2. And getting within 10%, that has value, but that has a lot less value in my opinion. If we can't get within a factor of 2, we might not be able to make this .NET thing work at all. If we can't get within 10%, but we can get within a factor of 2, we can certainly make it work. So I would say start coarse, start simple-minded. My canonical example of how things go wrong is the Alto I remember from many years ago, that people started complaining that the Ethernet wasn't working well for this machine. Investigation revealed that over the course of several months, the fraction of packets that could be received at this machine undamaged had fallen from 99.9 to about 15%. And it was still working. Okay? People were just complaining that it was sluggish. That's not what you want, right? It should have been instrumented so that when it went down to 98, which is way worse than it's supposed to be, an alarm would have gone off and somebody would have figured out that the repeater that the packets were going through was broken.
But, suppose we're in this .NET world, something like that happens. Where does that alarm go off? Maybe I don't, I'm sitting on my client machine using 6 different services, and there's nothing really wrong with any of the services the service provider could see. So who do I tell? Do I pop up a dialog box with this nice long error message saying,
Well, I'll tell you what I personally would like, sitting on my machine in Cambridge, connected by my Media 1 cable modem to the rest of the world. When things are not going well, I would love to see a dialog box that says, I've noticed that you're not getting very good service from the Economist website. It's a lot worse than it has been historically. And I checked things out, and I discovered that the service to the Media 1 DNS server is just as good as it ever was, and indeed the service to 3 sites on the West Coast is just as good as it ever was. And I checked out this and this, and it really looks as though it's the Economist web server that screwed up. Today, I have no idea, and I'm a geek, so I know a bunch of things I can try by hand to give me a hint about what it is that might be wrong. That could all be automated perfectly well, and I would love to see that dialog box.
I know you would, but most of the world would get no information.
No, I don't think that's true at all.
Most people don't want.
My wife is very technical, and she begs me to try to sit at my desk and try to diagnose why she's having problems with her MSN mail.
Right.
Which I can't do very well, but.
Well, another possibility of putting send this dialogue to is where we fix it.
Yes, that's the next step.
And if we do something to it, well, if it's, I get a lot of dialogues in Microsoft software that say, error 15, the transaction failed.
That's certainly not very useful.
Whatever.
Right?
And I, to some extent, I don't want to know a whole lot about what's happening internally in all the software. The fact that there's a T1 line between here and India that went down recently, whatever. Some people want to hear about more than others. To some extent, it's because they're sort of spectators. They like to sort of watch their computer work and watch the packets go around. But if there's ultimately, you'd like to get to the point where the system will be even smarter and send mail off.
Absolutely. Absolutely. But the first step is to do what I said.
Well, the thing you want to see on your screen, if you're somebody who doesn't care about the details, is there anything you should do, right?
Is there a way I can work
what
it
I
out?
want the system to say is, it's not your fault. You don't need to go fix your machine.
Actually, there's 2 things that I want. There's 2 things I want to see. One of them is that, but the other one is something that gives me some idea of what to expect. If it's only the Economist that's broken, I can go read the New York Times. Am I going to be able to read my email? Simple questions that bear directly on what I'm going to do in the next 10 minutes.
Yeah, and tell me when it gets better.
And tell me when it gets better. Absolutely. So I think John's absolutely right. But what John is asking for is going to require more cooperation from the people that are providing a lot of the infrastructure. Some of this stuff can be done without any of that cooperation. So it's good to start with the things that you have more control over, which you need anyway in order to do the other things. But I think John's absolutely right. The goal should be that the whole system decomposes in such a way that you can tell who's responsible for which parts.
Isn't that like an extension of the SMS that open view and type of thing? Because you have a client, or it's a state part of the network, and part of it you get the messages through SNMP and so forth. Basically, it tells you there are problems, etc. and so forth. If the issue knows there's problems, but this time you get the server sending the messages to the client. So just an extension of that model at this point.
Yeah, I mean, to the extent that the world is willing to tell me how well it's working, that's great. But today, it's extremely unwilling to do that. So I'm reduced to trying to figure it out by probing the world. And you can actually accomplish a great deal that way, even when the world is not being very cooperative. I think it's some recent PhD, I think it might be Stefan Savage, who just got his PhD from UW, who's done some interesting work demonstrating that, there are lots of sites you can't ping because they have ping turned off. But you can use TCP in slightly non-standard ways to extract a lot of information from sites that don't want to give it to you. And there's very little they can do about it.
So earlier you gave an example of people using web servers and Oracle. There's a lot of customers like NASDAQ who are deliberately moving away from models like that, and they're buying pure Microsoft products simply because of this issue, which is I want one phone number to call.
Well, that's great.
Screwed up. I just want this guy. It's his fault. I don't want to know why. Just fix it.
That's cool. That just moves this problem into a different space because the guy that answers the phone has to do the same thing.
Yeah, but
so this is great for NASDAQ, but me.
Responsibility because what they don't want is finger pointing.
Yeah, no. But you're missing my point. You're missing my point. The technical problem is exactly the same. The business situation is different and much better for us. But technically, the guy inside of Microsoft that gets that phone call is going to have to do the same things that we've been talking about because he is still confronted with this complicated system made up out of all kinds of pieces that came from different parts of Microsoft, and he has to figure out where the problem is.
He can't do anything about the Oracle bits.
You just told me there aren't any Oracle bits.
Yes, I understand. That's why they want the Microsoft only solution. I'm saying that there's no need to versify it, and there's lots of people to play with. Trying to keep the system running.
Hey, you're gonna have both.
IBM consulting services charges billions of dollars per year precisely to do that.
Some people are going to do the very conservative thing you say. Other people are going to build their systems in much more diverse ways. The technical issues, many of them are very much the same. In many cases, the issue is, from the point of view of the guy that answers the phone, the issue is to figure out that the problem is with either the SQL server or the Oracle server, whichever one it is, and know who to call, for Christ's sake. That's the huge challenge.
Sure, and there are plenty of businesses that make money just doing that, just being the phone number that you call, even though they don't provide you with any of the bits.
Right, and that's cool. And those people desperately need tools so they can do their job better.
Right.
And I think the tools they need are very similar to the tools that the guy needs who's trying to do it for himself. But today it's very different because they do their work in a very manual way. So they solve their problems with a huge amount of special training of people, which isn't all practical for the end user, but that's not what you want. And that's certainly not the business you guys are in. The business you guys are in is building the tools so that everybody can do this stuff. And then it's a business issue, who's actually going to do it.
So you mentioned one of the things that what we should aim for is, from a performance point of view, is getting within a factor of 2 of best performance and not being at 10 or 100. So what do you think are the big things that are going to get us from 10 or 100 to 2? I mean, is it things like inspecting when things fail, networks crash, computers die, or are there more fundamental things like system level interactions across different components, or
Well, I think the things you said are the first order things.
and do you think that'll get us to 2? So is that all we need to care about from the performance point of view? Is just identifying when things just totally die or fail? Or
No, I don't, because I think especially this is perhaps less likely to happen in a deployed system, but Although, well, even in a deployed system, even if things don't die, they can certainly get overloaded. And so you can get into a situation where something is taking 5 times as long to respond as the designer had in mind, and perhaps as a result of that, you're getting other timeouts going off, and so that can easily cascade into disastrousness. So that's one thing that can happen is overloads. But the other thing that can happen, which isn't perhaps so likely to happen in the deployed system, but certainly can happen in the design phase, is that I was talking to someone from the office group a few years ago, and they were complaining bitterly about the experiences they'd had dealing with Exchange, where the story, I don't know whether this is true, but the story the office guy told was, okay, the Exchange guys invented this mappy thing, all these RPCs you can call to do email stuff. And so the office guys read the spec, and I said, okay, great, we're implementing Outlook or whatever it is. We'll call all these procedures and get the stuff done. And it seemed functionally fine. And then, according to his version of the story, the Exchange guy said, hey, you're calling too many of our procedures, and they instituted what he characterized as the RPC police. And the office guys were forced to do a whole lot of re-engineering to cut down on the number of RPCs they were doing, calling these perfectly innocent-looking procedures. I'm sure the Exchange guys would tell a very different story about how this whole thing went. But it was pretty clear that two people had models about what performance you could expect across this interface, and the models were very different. And I've had a number of experiences like that, both personally and in systems that I had a chance to observe fairly closely. So I think there's that class of issues as well.
So why is it that this kind of infrastructure isn't more pervasive? I mean, it seems very obvious that from a user point of view, from a designer point of view, everybody's point of view, it's going to be beneficial, right? So why isn't that you're saying it's countercultural?
Which kind of system?
Well, these sort of this pervasive
things.
Infrastructure that tells you what's gone wrong.
Oh,
Features. It's in conflict with features.
Yeah. Is it really?
Well, it's definitely different. It's in conflict with features for resources, for sure.
Yeah.
And
okay, that's fair.
there is this problem with I mean, in a way, this is an aspect of TCO, right? And one of the reasons that TCO does poorly is that most customers are not sophisticated enough to buy based on TCO. They'd rather have features. Right. But it's clear that it's a funny marketing problem. But certainly, features are much easier than this stuff. Especially when there's multiple players involved, and it's just very for Microsoft in particular, it's very countercultural. There are other organizations where the emphasis is very different. In the phone company, they worry about these things a lot, and they have a very different set of priorities. But that's feature phones do not have very many features. That's correct. Well, that's not true, actually. There are thousands of features, it turns out. But yeah, the priorities are very different. And that's because they come from a culture in which people are accustomed to thinking about what it's going to cost to do things over 10 years. Most organizations, even large companies, don't have that culture. And typically the guy that makes the purchase decision, by the time the bill comes due 3 years later, he's moved on to some other job. And the end users usually aren't very conscious of these things. I mean, they know that they're frustrated today, but it's hard for them to make the connections.
So here's another question. Let's mention that we
but actually, just to finish this up, I don't really understand the answer to your question, because it does seem to me, as I said to Bill 5 years ago, that we can make a huge amount of money by doing this. And we're not doing it. And it was a bitter disappointment to me when the Oracle network computer collapsed. Because when the network computer was announced, there was a huge wave of enthusiasm for this stuff within Microsoft. About all that stuff, right, exactly. And then when the network computer collapsed, everyone lost interest. Bastards. But then much later I found out much later I found out from my current boss, Dick Brass, who used to be the VP for public relations for Oracle. He said that he basically invented the network computer, and it was complete vaporware. There was never anything behind it. Now I know that John was in an engineering organization that worked on the network computer, so he probably has a somewhat different view. But Dick's story is that it was the creation of Dick's and Larry's fevered brains.
Well, plus some really good Potemkin engineering.
And there was never any chance that there would actually be a network computer.
So, looking at so if you want to have a system that's pervasively monitorable, that's a bad word.
It's
pervasively monitorable.
Monitorable, yeah.
Then this has an architectural implications. You have to build a system that, for example, is going to be able to take logs of things from different components and put them all together. It means we're going to have to be passing around unique transaction IDs, for example, between components that will be able to do this. We just have the option of doing that, and we'll have to have some sort of, and this will interact in the transactional mechanism in some way or whatever. To the but to the extent that this requires, doing this well requires some basic architectural support to the system, as opposed to something that we sort of can slap on later. Presumably now, if ever, is the time to actually get this into the architecture.
Sounds good to me.
So how do we do that?
Well, you have to figure out, you mean, who do you talk to, or?
Yeah, I mean, what's the process that's being followed to actually bind all these things together at the moment?
I haven't a clue.
I'm lost. Okie doke.
Ask Pat Helland, he might know. And he's pretty easy to talk to. Now, there was this giant NGWS, or as Rick Rasher calls it, NGWS. There was this giant NGWS architectural effort in the spring. There were 8 groups that went off to work on various aspects of NGWS. And I think they produced extremely mixed results, and a lot of their reports I couldn't really understand at all. And my experience has been that if I can't understand it, that almost certainly means it's because it's all screwed up. I used to work for Xerox, and then when I went to work for DEC, which was a real computer company, I was very respectful. I said, Xerox is flaky copier companies. These guys have been selling computers for 20 years. They must know what they're doing. So if they tell me that they have some great scheme for processor, operating system, or whatever it is that I can't understand, it's probably because they know more about it than I do. But then after 4 or 5 years, I noticed that all the things that I have not been able to understand failed. So now I'm much more hard-nosed. If I can't understand it, I assume that it's bad. It's probably not always true, but it's definitely what I assume. And it's been a good rule to follow at Microsoft also. Just because I can understand it doesn't mean it's good, but if I can't understand it, there's big trouble.
Which ones could you not understand?
I've never been able to understand Exchange, for instance.
Coming out of the NGWS efforts.
There was, let's see, I couldn't really understand the event and notification stuff, or the messaging stuff, or the security stuff. The UI stuff I could understand a little. I was actually in that group. It was pretty confused. And there was all this babble about having a new shell, which I couldn't understand at all, because it seems to me the shell's not very particularly important. And I don't really want a new shell because the old one works fine. What I don't like is that the old one's been merged with Internet Explorer, so it now works much less well than it used to. But then I realized that when Bill says new shell, he didn't really mean that. What he meant was what he basically wants is a new style guide for user interfaces, which makes much more sense to me. So that, well, just more than that, because the style guide is something that influences everyone who writes an app. Because you're supposed to do your UI in accordance with the style guide, right? So that's actually quite profound. The programming model stuff I liked actually was mostly about this loosely coupled stuff that we were talking about. I can't remember all the others. But there were about 3 that I liked, and a couple that I thought were neutral and 3 or 4 that I couldn't understand. But actually, I think the story that was told at Forum 2K was a big improvement. I think this vision of net services and the client as the having the code that runs on the client having the opportunity to integrate a lot of stuff is I think that's a great story. We done?
Yes.
Thank you.
You bet.
Speaking of things that definitely didn't work.